Okay, cool. Well, we gotta clear off some screen here. Can't let you see the answers before we do it. All right, welcome. We're gonna do first our post-it note. Might as well, right? I mean, what's the point of posting something and not giving the answer up? Okay. Let's see. What do we know? Well, based on our information that we posted before, we know that sine theta is what? Y over R? I guess I should write it properly, right? Y over R. And that equals 1/2. And we have that tan theta is root 3 over 3. And we need, well, we obviously need cos. What's cos? Well, the theta is going to be the same, right? So let's think about what our numbers should be. Tan theta is sine theta over cos theta, and well, we already have the we already have sine theta and we already have tan theta, so let's just cross multiply and get cos by itself. So then we've got cos theta, so it would come up over there, and then tan theta would go down there. Is sine theta over cos theta, or tan theta. And well, sine theta we know it's 1 over 2, and tan theta is root 3 over 3. So let's simplify. It's going to be, well, we've got a fraction on the top and a fraction on the bottom, so we just multiply by the reciprocal of the bottom fraction. So this would be 3 over root 3, right? And we can simplify this further, and we'll multiply by the radical, the conjugate. So we'll get a 3 on the bottom. We'll get a 1/2 times 3 root 3 over 3 will cancel out, so we've got cos theta is root 3 over 2. Okay. And now let's find our answer here. So Cosquared theta is, we got root 3 over 2 squared plus tan squared theta. Tan is root 3 over 3. We got root 3 over 3 squared. Sine theta is 1/2. And then we've got cotan theta. Remember, the cotan is just 1 over tan theta. So then 1 over tan theta is 3 over root 3, right? Then that's also squared. Okay. And then, so cotan theta is 3 over root 3 squared. And then we've got cosquared on the bottom. And cosquared is, we've got root 3 over 2 quantity squared. Oh, okay. And then we've got it all filled out. Now we gotta just simplify. Well, root 3 over 2 squared. We square the radical, so we've got 3 over 4. And we've got, let's see, 3 over 9. Did I write that right? I think so. Yep. We've got 3 over 9 times 1/2. And then we've got what, 9 over 3. And then on the bottom we've got, let's see. We've got 3 over 4. Okay. And then what do we do? Well, we will simplify a bit. So the 3 and the 9 cancel. We've got a 3 on the bottom, so 1/3. And this 9 and this 3 will cancel, so we got 3 on the top. And that's it for that. We've got 3 over 4 plus 3 times 2 is 6. 1/6. Multiplied by 3. And we've got 3 over 4. And then what do we do? We've got to find a common denominator. Let's say 12. We multiply by 3 for this one would give us a 9 over 12. And multiply by 2 on this one gives us 2 over 12. So 9 plus 2 is 11 over 12. Times 3. And now we're going to multiply by the reciprocal of 3 over 4. So that would be 4 over 3. And the 3's will cancel out. And, well, then the 4 will go into 12. 12 is 3 times 4. So this 4 and this 4 will cancel out and we're left with the 3. So we got 11 over 3. Boom. If I didn't mess up any numbers, that should be the answer. Let's see. I have sine theta is 1/2 and tan theta is root 3 over 3. If we cheat, we know that theta is going to be pi over 6. And cos theta should be root 3 over 2. Which it is. Nice. Okay. Now let's see, how did we do with the formula? We've got cos squared, so root 3 over 2 squared, check, plus tan squared theta, which is root 3 over 3 squared, check, times sine theta, which is 1/2, check, cotan theta, which is 1 over tan, which is root 3 over root 3, 3 over root 3 squared, check, and cos squared on the bottom, 3 over 2 squared, check. I think we're pretty good so far. Pretty good. And then multiply it all out. Do we square that right? Yes. Square that right? Yes. 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 Alright. I'm pretty sure it looks good. Looks good. Right team. Right team. After that, let's do, because I don't really have anybody to tutor right now, I'm gonna practice some differential equations. But we'll start at the beginning. Let me finish this little thing here. Okay. Now, I did a bunch of differential equations before, and I've actually got a whole... I don't know, how far did I get? Chapter 3 or 4? Chapter 3? So I've got quite a bit on the beginnings of differential equations. And let's start with kind of an example of what a differential equation looks like. And a good example right off the bat is an object falling. Differential equation. I wonder, I should probably check and see what I'm doing here. And how's YouTube looking? Probably working just fine. Yeah. All right. An object falling. Let's see. What kind of diagram should we draw here? Like a little, let's give it some kind of mass. This object has a height from the ground of y of t. And it has a mass, right? Oh, hey bud. How's it going there, Grump? And we've got, you know, just regular high school physics and whatnot. You have mass times the acceleration, so negative mg. And that's when it's falling down, right? Bing. And the only force acting on it is gravity. So we say that the differential equation y double prime equals whatever they have in here, just negative g. And this will be of time. Function of time. The height is a function of time. We assume its weight is its mass times its acceleration, right? So we want to know what its position is according to time, not just its acceleration. That's where differential equations come in. So this is a very simple one, because if we just integrate this equation, we'll have y prime is negative g times t plus some constant. We don't know what that is, but we're going to call it constant 1. And then we'll integrate it again. Oh, I don't want. and we'll get, what is it, negative g over 2 t squared plus some first constant times t plus some second constant. And that's just the beginning of what a differential equation looks like. We've got some function that we integrate and we find the solution to it in this context. So if we plug this back into here, we'll get the answer. Now that's a very simple one. They get more complicated. There's partial differential equations. There's, oh, I don't even know. There's tons in physics. Heat equations, fluid dynamics, lots of stuff. But I'm only going to do the early stuff. Until somebody decides to stop me and talk about, I don't know, trig or high school or calculus or any cool stuff like that. So let's look and see. Let's see. What did I start with? Examples of differential equations. Okay. We'll leave that right there. So here's another one. We've got y prime plus 2y equals 0. And we want to know for what value of k will this be a solution. Is that the way they wrote it? Yes. So what value of k will this work out to be? Well, first we'll take the derivative of this. So we'll have our y prime of t. And this is an exponential function, so the derivative of e to the kt will just be k e to the kt. And that's all we need. Let's plug it in. So y prime is k e to the kt plus 2 times y, which is e to the kt, equals 0. And the funny thing is this is common on both sides, in both terms, the e to the kt and e to the kt. So if we just kind of divide by it, it'll cancel out. So we'll just have k plus 2 equals 0. And then that just gives us k equals to negative 2. And that's our answer. So that tells us that if we plug in negative 2 in for k in this formula, so y of t equals e to the negative 2t, this is a solution to this differential equation. So what happens with another one? That looks more complicated. Always gotta check back to my notes because I can never remember on the top of my head. Plus, what is this? Sine of 2t y equals 0. And again, we're going to try and find the value for k. So we've got y of t equals e the k cos of 2t. That is our differential equation, and that is our solution that we're going to try and find. So what are we going to do? Well, let's first start by taking the derivative of this function. So y of t. Now the derivative of this, if you remember the chain rule, so And it's going to be the e to the k of cos of 2t times the derivative of k cos of 2t. Which is what? What is the derivative of cos? Derivative of cos is minus sine, I believe? Yeah. And so this will be negative. And then, so there's a 2 in here, so we have to bring that out. 2k sine of 2t times e to the k cos of 2t. And now let's plug it in. So this is our y prime. Make sure I gotta write that right. Then we've got negative 2k sine of 2t plus sine of 2t. Oh, don't forget, brains, you can't forget. You're writing it wrong. Scroll all the way down now. We've got y prime, which is negative 2k sine of 2t e to the k cos of 2t. And then we've got plus sine of 2t. And then we've got y, which is e to the k cos of 2t. E to the k cos 2t. And this all equals 0. And look what common factors we have again. We can divide by this this sine. So first, what I'll do is I'll just take them out, make it easier on you. So we've got negative 2k right there plus 1 times sine of 2t e to the k cos of 2t equals 0. And if we divide by this, it becomes 0, right? So there's gone. It's just a 1. And then we're left with, I don't need a bracket anymore because it's not multiplied. So we've got negative 2k plus 1 equals 0. Negative 2k equals negative 1. And k equals 1/2. Boom! Which again means if we plug in 1/2 for k, this will be the final solution to our differential equation. So let's see, do we have any slightly longer ones in my notes? I mean, it is just the first chapter and first section, really. So you know what? Here's a good one. And it's where still kind of just introduction to differential equations. I'm gonna look up this over here, and I need this one by me because it's a little lengthy. We've got, okay, a time equals t equals 0. So t0 is 0. We've got an object of mass m. Some object is released from rest. Now this is important. It's released from rest at a height y0. At height y0 above the ground. Let g be the gravitational acceleration. Blah blah blah. Derive an expression for the impact time at which the object strikes the ground. We need an expression for the impact time. What is the velocity when it hits the ground, and express it in terms of y0 and g and all those standard things. Okay. So we've got, just like our initial one, we've got some y0 height was our mass, blah, blah, blah. That's him. And it's falling. It's got a gravitational acceleration of g. Okay, okay. And we've got impact time. We've got a height y0. We need t impact. I think that's what I wrote. No, never. It's fine. We have our differential equation, which we started with before. So we've got y double prime of t equals what? Negative g? Yep. And we're going to do just like the last before. So we'll just integrate y prime negative g times t plus t1 and integrate again. So y of t equals negative g t over 2 plus c1t plus c2. Now we've got y prime of 0. Now, what does y prime represent? If y double prime is the acceleration, this would be the velocity, and this here would be what? Position, right? So, what information do we have? We've got y prime of 0, which means the velocity was started at rest. So y prime of 0 is 0. And so that would mean that our y prime of 0, I should write this not ugly. That means our y prime of 0 is 0, which equals negative g times t, which is 0. Is right, we've got a 0 in here. And plus some constant c1, which then implies, so this is 0, well, c1 is 0. Okay, our t impact is y0. So at the time that it hits the ground, well, it doesn't have any height, right? So our y of 0, or our position, which is our t impact. No, I don't want to say that. How do I want to say this? T impact is when we've got y of 0, not y0, when y equals 0. Yeah, that's better. So then when y equals 0, I've got to read my notes here. They're a little odd. But t good. Ah, I forgot the one important step. where is its position at time 0? So its y of 0 is, well, it's y0, right? Its height, it's y0. But this is at time 0, and it's this position function right here. So we've got negative g over 2 times 0 squared plus c1, which we found out was 0, but I'll write it in here anyways, just to continue. And then we've got plus a second constant. Well, this is 0, and this is 0. So c2 is equal to y0. So its initial height. Now we can go ahead and continue. So then we've got to think about, so our t impact is when y is 0. So its position is 0. So if we have 0 equal to negative g t squared over 2 plus c2, because c1 is 0. So c2 is y0. We will find our impact time. And what is our impact time? Well, we'll take a y0 over. We got negative y0. And this is negative g over 2 t squared. Well, we'll cancel out the negatives, because we'll multiply it. And we've got 2y0 over g equal to t squared. So t equals the square root 2y0 over g. This is our impact time. Of course, we're assuming different resistance. This is just the standard differential equation. Now we need to say this in terms of velocity. Well, velocity is negative g times t. Well, velocity of time is negative g times the t impact, which is the square root of 2y0 over g, which then, if we take the g onto the inside, we got negative. We've got 2 times g squared, because if you take it in, it just becomes squared. And we've got y0 over g. One cancels out with the other, so our impact velocity is negative square root of 2gy. There we go. So what we found is we had some object of mass m. It was released from rest at a height of y0, and we needed an expression for its impact time. And we also needed to express its velocity at impact time. So we drew our little graph. We had our little variables written out. We had our differential equation started, went from its acceleration to velocity to position, plugged in our numbers that we knew initially, and then we solved. Kept going. Okay, let's stew on that for a minute here. Stew on that while I look for another one. And another one. Difference between nonlinear and linear. Let's take a look. Linear or non-linear? I mean, it's important to know, but it's not not mandatory. So let's skip one section. First order linear differential equations. Yeah, okay. We did some examples. I mean, first we started with our post-it note that we posted, and hopefully we did it right. I don't know. I feel like I got a different answer the first time. Differential equations. We started with just a quick little introduction. We did another example of one, and we did a longer example of one, which is just the starter one. Now we're going to talk about solving the linear homogeneous differential equation. And that is, so the linear homogeneous differential equation. Now, if you want to do calculus or stuff, just let me know, because I've got notes and stuff prepared for that. I just figured I'd do this anyways. Let's see. The linear homogeneous differential equation is of the form, well, it's first order. I should say first order. We've got y prime plus some function, we'll call it e of t, y equals 0. I'm using the t variable. Lots of other textbooks and whatnot will use the x variable. You know, difference doesn't matter. And so this is just the simple, standard, first order linear differential equation. If we want non-homogeneous, that is when it equals to some other function. We'll call it g. So like y prime plus some function y equals g of t. And that's okay. We're gonna start with just the linear, the homogeneous one. So this means that y prime equals negative p of t times y equal, or not, they're equal to each other, which means we need a function whose derivative is equal to negative p of t. So the only one you really think about is the exponential function. So our y is equal to e to the negative p of t, which means if we have a solution, we need our y equal to e to the negative integral of p of t dt. This is the what do we say? It's not really a general solution. It could just be just a simple solution to the linear homogeneous differential equation. So, an example. We've got y prime plus 2 times t, y equals 0. And what we want, of course, is we want to solve our y. And let's go. Let's say, let's just follow the formula. So this right here is going to be our p of t, which means if our answer is y equals e to the negative integral of 2t dt, then Well, the integral of 2t is just t squared. So we've got e to the negative t squared. Well, let's try it. Does that really work? Now, you would normally add a constant, but we're not going to in these cases. I'm not. Let's see. What would be a reason not to add a constant? Because the initial values will figure it. We'll cancel them out. Really, they're not as important as just finding the general equation in this case. So, as a check, we're going to set y equals to e to the negative t squared and differentiate that. So y prime is going to be, well, we got to have the derivative of this, which is e to the negative t squared times negative t squared prime, which is negative 2t. I'm just going to write negative 2t e to the negative t squared, and we're going to plug that in. We're going to plug it in over here on the left. So we've got negative 2t e to the negative t squared plus 2t, and y is e to the negative t squared equals 0. Yeah, they cancel each other out, so 0 equals 0, and we're done. So we know that's an answer. Let's see. The general solution has a constant in front. So usually when you go differential equations, you have a general solution, because sometimes you'll have a particular solution, a complementary solution, you know, and there'll be multiple different solutions that add together that gives you the entire solution to the problem. Because there could be more than one way. So let's say I can't think of one off the top of my head. We'll come to it later, I guess. That's okay. So now we're going to talk about the general solution. Which will be y of t equals constant e to the negative, or are they going to say negative? Yeah, negative integral of p of t dt. Okay. Here's one that actually has a value. So now we're going to find full-on solution. We've got t y prime plus 2y equals 0, and then we've got an initial value, so y of 1 equals to 5, which this form doesn't look like the original one, right? So let's divide by t first. We got y prime plus 2 over t, y equals 0. We're going to divide by t. And now we'll use this general solution. So we use y of t is equal to some constant b, and we've got e to the negative integral of 2 over t dt. I don't need a bracket there, I guess. And what is the integral of 1 over t? Well, it's natural log of t. Okay, so then this y of t is equal to c e to the negative 2 natural log of t Well, we got to use natural log rules, logarithm rules. And so -2 ln of t is actually equal to the natural log of t to the -2. And that will make things easier, because then we'll have y of t is equal to c e to the natural log of t to the -2. Natural log and the e will cancel out. We've got y of t is equal to c times t to the -2, which is equal to c over t squared. Now, we're going to try the initial condition. Our position function has a t value of 1 and a final value of 5. So then we've got 5 is equal to c over 1 squared. So c equals 5, which means our final general solution are all the solutions of the form c over t squared. In this one, I'm not sure. Probably. It's the only one that works in this case, and there might be some, like, there might be other techniques that I don't know. I'm just following the first year course. Pretty sure this is all the solutions. I can't think of anything else on the top of my head. Anyways, I'm just gonna finish. Y of t is equal to 5 over t squared. Yeah, by carefully considering t equals 0. Yeah. I did do a complex analysis course, but it's been so long since I've done those higher year courses, and I never really 100%ed them anyways. Like, even redoing this stuff, I do it just so I relearn it. It wasn't my strongest subjects. I'm only doing these because I got no one to tutor at the moment. Yeah, with potentially different constants. But we've got an initial value, right? Oh, but you know what's interesting? I actually have this going to YouTube as well. I'm dual streaming it. The only problem is YouTube, I find extremely hard to find live channels. Like, yeah. Well, how much have you studied, bud? I'm assuming you're in it or have finished a degree, possibly higher. Maybe physics. Integrating factors. Yeah, math, bachelor science. Yeah. I do as well, but I went and was uncool. I went to commerce right after and didn't retain all my math knowledge, and I went and worked in a bank for like 4 years. So coming back to the math that's actually entertaining is more complicated when you've forgotten all the early stuff. What am I doing again? 2.2. Okay. Let's find the general solution of each of these initial value problems. They are very simple though. Like pretty much one step. I'm gonna go on to the little bit tougher second step problems. We've got the y prime minus 3y equals 6. We've got y of 0 equals 1. So let's see. I'm going to say that mu of t is equal to e to the minus 3t. This is a little odd. It's not what I've covered yet, but you'll see in a second here. E to the minus 3t is going to be multiplied onto each part of this function. So then we've got e to the minus 3t y prime minus 3e to the minus 3t y equals e to the minus 3t times 6. Okay? Now, this looks interesting. This part here. And why does it look interesting? Well, remember the derivative of a product of functions? What should I say? F and G? What does the product of two functions look like? What is the product rule? Well, we've got f times g prime plus, what is this? F prime g? Well, you can change the order. Technically they write it g f prime, but I wanted to write it that way. It looks interesting because if f is e to the 3t, negative 3t, and g is just y, well, that would equal e to the negative 3t times y prime plus, well, f prime would be negative 3 times e to the negative 3t, and then, well, g is just y. If you notice, they are the exact same, which means we can write this first differential equation as e to the negative 3t times y prime equals to, and I'm just going to write this down again, 6 times e to the negative 3t. And I'll write it a little nicer. Did this stream just cancel? No, it's still working on my end. Not even drop frames. Interesting. Just looks like the stats are offline. No, it's still going. Okay, good. Okay, so what do we have now? Well, if we integrate this, we'll have e to the negative 3ty, because we're just going to integrate both sides. Right? Okay. Okay. Then, well, what's the integral of this? well, you divide by -3, so I'll write it over here for those that don't know integrals that well. We've got 6 comes outside, so e to the -3t, and of course we'll write dt. And we got 6 times e to the -3t, and then technically you divide by -3, but I'm going to just write it as a fraction, 3. And so that the 6 and this 3 will cancel, and we got a 2. And there's still the negative in front. I'll just rebel that up. So this equals -2 e to the -3t. And, well, plus some constant. And you want to write that constant in there. Now, well, we want to just get the y by itself, so we'll multiply by e to the +3t along everything. So then we'll write this kind of in brackets and go e to the 3t. Now the -3t and the 3t will cancel out because you add exponents. And this will now have, well, this one will cancel out as well, so you'll have a -2. And you'll have still your constant plus constant e to the 3t. And that's our y. Now we impose our initial condition. Y of 0 is equal to 1. So y of 0 is equal to 1. So when t is 0, y is 1. We got 1 equals -2 plus c e to the 0. Well, e to the 0 is just 1. And we're going to scroll down just a little bit. We should react it a little. And then we've got, well, we'll take the -2 over, so that's +2. We got 3 is equal to c. So then our final solution, y of t, is equal to -2 plus 3 e to the 3. Oh yeah! I will be right back. I have to use the restroom. Stew on that for a second. Okay. What do we gotta do? Let's see. Hey, Sneaker! thanks for the follow, bud. Much appreciated. If you have any problems that you want to work on, you know, between high school and first year, let me know. Because it's better to work on stuff that people are engaged in than just my random stuff that I do for fun. Okay. Should we do another one like that? Yeah, let's do another one like that. A little bit more complicated or simple? Maybe we'll do a little bit more complicated. We've got 2y prime plus cosine of t y is equal to -3 cosine of t, and we've got an initial condition. Y of 0 is equal to -4. Now, what would you do as your first step? What would you think about doing? Wow, I'll tell you what my first step would be. I'd divide by 2. Real simple. I'd have y prime plus cosine of t y divided by 2 equals -3 over 2 cosine of t. Interesting, interesting. And I want the our solution that we're going to use, so our mu of t, I'm going to use e to the sine t over 2. And now, why would I choose that? Well, remember, I want this piece, this cosine t over 2, to be integrated into this exponent. So what is the integral of cosine? Well, the derivative of sine is cos, so the integral of cosine is t, or sine t. And since it's divided by 2, we don't have to worry about that too much. And now let's multiply the whole equation by mu of t. Whole equation. Then what do we got? E to the sine t over 2 y prime plus cosine of t over 2 e to the sine t over 2 y is equal to -3 over 2 cosine of t times e to the e to the sine t over 2. What does that give us? Well, this looks again like e to the sine t over 2 times y in the derivative. Then this is still the same, 3 over 2. Oops. Cos t e to the sine t over 2. Now I'm going to integrate both sides. Ching, ching. With respect to t, of course. So this one we already kind of thought about we know that the derivative of sine is cos, and it's going to come down, and the 2 is going to be there, so this will be pretty easy to integrate. It will literally just look like a minus 3e to the sine t over 2 plus c, and we're going to have an e to the sine t over 2 times y. Negative 3e. To write that a little better. E to the sine t over 2 plus a constant. And then we'll multiply the whole equation by e to the negative sine t over 2 so that the exponents cancel out and we're just left with y on the left hand side. So multiply by e to the negative sine t over 2. So these will cancel out, so we're just left with a y. This one will cancel out on the negative 3, so we got negative 3 plus a constant times e to the minus sine t over 2. Now we plug in our initial condition. We got negative 4 for y, and t is 0. Now what's sine of 0? Sine of 0 is 0. We can use, you know, I'll open it up and I'll show you. Where's my unit circle? There. Give me a second. Ha! There's my unit circle. So, sine of 0. So 0 is our degrees, or 2 pi. And sine of 0, sine is our second number. Sine of 0 is 0. Good. Perfect. So this is negative 3 plus c e. Well, negative 0 is still 0. 0 divided by 2 is still 0. So e to the 0. And like we know, e to the 0 is 1. Negative 4 equals negative 3 plus c. Take the negative 3 over to the other side, so add. And then we get negative 1 equals c. So then our final solution, y of t, is equal to negative 3. Right in here. C is minus 1. Minus e, the negative sine e over 2. There we go. Not bad. Although I should write it a little bigger. All right. That was pretty good. Now we did one before that was had a natural log in it. Maybe we should do another one similar to that. Or do we all know the natural log rule? Maybe I should do a little bit of a look at natural logs. So log rules. It's just a tangent. Log rules. Well, what's the best way to put it? Do I have a reference sheet with a bunch of these on here, so it just makes it so I don't forget any? Nope. So let's try not to forget any. We've got log of base e is natural log. And we've got log without a number in the bottom is assumed. So let's say log of x is, and this is assumed to be base 10. If it had log 2x, that means it's base 2. And so what does that mean? Well, it means, let's say log 2x is equal to, geez, why do I forget all of a sudden? I know. When in doubt, when you forget something. That's not what I wanted though. Right, that's what I wanted. Log of 2 well, you know what? Let's do log of 16 equals 4, which means that 2 to the power of 4 equals 16. See that? I don't want this anymore. I want to do some other log rules. So there's the sum of logs. I'm just going to use natural log because it's easier. So natural log of x plus the natural log of y is what? When you sum them together, I'm just going to do this so I don't forget, is the natural log of x times y. If you've got a, or I should do the multiplication first. Natural log of x minus natural log of y. This is the natural log of x divided by y. If you've got natural log of what's the next one on the list? Ah, the exponent one. X to the a. This is a natural log of x. If you've got like a base, natural so okay, log of 1 is 0, because a number to the power of 0 is 1. What else? Right. If you've got e to the natural log of x, let's say, these will cancel out because they have the same base, so then you're left with x. And this last one, I'm just going to write the way they have it in here. Log of a to a to the power of some x. That will also cancel out and give us just an x. Reason being is you'll probably just use this rule right here and bring the x down, and then you're just left with same base equals 1. Which I guess I should write down as well. Log of the base of itself is 1, because to the power of 1 will give it its own value. That was just a log rule tangent there. Okay. Wanted to do that because this is the next differential equation. We got t y prime plus 4y is equal to 0. And I'm not sure if there was an initial value with this one. No, we just wanted the general solution. So we don't even have to plug in values for this one. Okay. If we don't have to plug in values, then we just leave it as the C, basically this form. We don't have to plug anything in, we just have it left with a constant. Okay. This one we're going to divide by t first to get it into that form, right? We want y prime plus p of t times y equals 0. And so y prime plus 4 over t, y equals 0. We're going to use e to the y equals our e to the negative integral of p of t, which means we're going to have y equal to e to the negative integral of 4 over t dt, which means, well, the integral of 1 over t dt is the natural log of t. Oh, I'm going through this so fast. I mean, basically, that's how fast your professors go, too. They only stop when people ask questions. So, let's keep it going. We've got y equals e. So if 1 over t is, the integral of 1 over t is natural log of t, we'll bring the 4 out. We've got negative 4 natural log of t. And if we use that log rule, so a natural log of t is natural log of e to the a. And we'll get y equals e to the natural log of t to the minus 4. And remember before that e ln of x is equal to x. They have 2 natural log rules. We're going to have y equal to e to the negative 4. And we always have to have the constant in front, right? I should write that in front. So we've got a c t to the negative 4, so y of t is equal to some constant over t to the power of 4. And that's the answer. That's our general solution. If we had a value, we could plug it in and away we go. This one looks a little bit more complicated. However, I know it won't be. We'll go there. We've got y prime Wait, did I write this right at all? Oh, yes. Y prime over e squared plus 1 times y is equal to 3. Now, this does not look like y prime plus p of t equals 0. That does not look like that at all. But that's okay. We will manipulate it so that it does. We're going to multiply the... I guess in high school they call it cross multiplication. We'll go like that. But if we think about it in general terms, what we did was we multiplied the left-hand equation and the right-hand equation by this denominator. We've got y prime equals to 3 times t squared plus 1 times y. Now we'll bring it to the other side. We got y prime minus 3 times t squared plus 1 y equals 0. Well, now we've got our form. So then our general solution, y of t, is going to be some constant times the negative integral of this. Well, there's a negative sign in there, so we're going to keep it in. Negative 3 t squared. I'm going to write it in there. Maybe I should write it a little bigger for you. Yeah? I mean, probably look better. Y of t equals to some constant e negative integral negative 3 times t squared plus 1 dt. Okay. Now, what is this integral? Well, the minus sign's turned into plus, right? So this is a little equal to up top. We've got... I'm going to split it up, make it a little easier. So we've got 3 times t squared. And we'll just continue distributing the 3. So we've got plus 3 dt. Which then this equals... Well, the integral of t squared would be t cubed over 3. So then the 3's would cancel out. So 3 over 3 t cubed plus, well, the integral of a constant is just 3t. So the 3's would cancel out and we're left with t cubed plus 3t. So that means our y of t is equal to c e to the t cubed plus 3t. And that's it. We did it. QED. QED. I don't remember what QED stands for, though. I just remember using it all the time. Need a shot of water. Let's see. Okay, next one. Let's have you guys do this one while I go grab some water. We've got y prime plus 2y equals 1. And as a hint, what? It is easy though. For differential equations, this is like first chapter, bud. Okay, okay. GG easy. I'm gonna give you a hint. U of t is equal to e to the 2t. I'm gonna go get some water. Tell me what the answer is by the time I get back. We've got books strewn everywhere on the ground to go and flip through. Okay, what's the answer? What is the answer? I'm sure you probably already know already. Answer is 5. Well, I mean, could be. Could very well be. There's 5 viewers. That if that was the question. No. Okay. We're gonna multiply the equation, both sides, by u of t. We've got e to the 2t times y prime plus 2e to the 2t y equals, well, 1 times that is just e to the 2t. Now, do you know what the answer is? Well, maybe. We can tell again that this here is going to be a product rule of 2 functions. The denominator. This is going to be the product rule of 2 functions. We've got e to the 2t times y. And that's going to be the derivative of those two. This is going to be equal to e to the 2t. So let's integrate both sides with respect to t, obviously. And, well, the integral on this is just going to cancel out the prime. So we've got e to the 2t y. And the integral of e to the 2t is just 1 over 2 e to the 2t and plus some random constant. Then we've got this e to the 2t, we want to get rid of it. We got y equals, we're going to multiply e to the minus 2t because the exponents add and cancel out. We've got 1 over 2. Well, these ones will cancel out as well, plus c e to the minus 2t. Ah, the good times roll. Done. Done, done, done. Okay, we've done enough of these, haven't we? Or have we not? I'm thinking maybe one more. A little bit more complicated. And then we'll try the next section. The little box. In math, lots of times you'll see them write a box, or I think some professors will write QED, and it's to symbolize the end of a proof, or the end of work. And I don't mind actually writing it. The little box is entertaining. I fill it in. Most people just draw the square. But this next one, y prime plus y equals t. This one is kind of interesting because it's so simple. Yet it's a little bit more complicated than the other ones for some reason. When you grab a beer, oh, so do I. Actually, I might go grab a beer later. That sounds like a good idea. Math and beer. It happens all the time. This one again, we're gonna do the u of t, and this is only a 1 in front, so we just got e to the t. It doesn't seem that difficult, does it? Multiply the left and the right hand side by e to the t. We've got e to the t y prime plus e to the t y equals t e to the t. Doesn't seem too difficult. This here again, as we've gone through before, looks like the derivative of a product. And we need to have this side. Oh, well, now we need to integrate both sides. Well, the left-hand side is easy because it just cancels out the prime. So we've got e to the t y. And then the right-hand side is a little bit more difficult. We have to use integration by parts. So we're going to go u equals t. U equals derivative of t, which is just 1, so dt. We're going to go dv equals e to the t. And then the integral of e to the t is just e to the t. And the integral of u dv is equal to uv minus the integral of v du. That is the integration by parts formula. And so let's plug it in. uv, so t e to the t, minus the integral of v, which is e to the t, and du is dt. So this is not too hard at all. E to the t y, t e to the t. Integral of e to the t is just e to the t, e to the t. And we're still going to add some constant at the end here. Now, we're going to get rid of this e to the t on the original function. So y, we're just going to multiply by the negative e to the t. We've got t minus 1 plus c e to the negative t. That's our solution. I feel like I should move my camera. It always looks like I'm away from you guys. I should just put it right in here so you can see me being less cool. This one looks kind of actually interesting. What's 27? Okay, a little more complicated. How much space do I have left? Oh, I got quite a bit. Okay, cool. Yeah, that's pretty good. This problem. Okay. The most advanced stuff you did was quadratic equations. Well, you in high school, right? I don't know if that's play video games and get dumber? No, you can't. You won't get dumber playing video games. Surprisingly, you actually get slightly smarter playing video games because you have to problem solve. You have to think critically. You have to learn, and you have to have reactions. Video games are usually actually pretty good for your mind. Surprisingly, there's a TED Talk about that too. The only thing is channeling about it, right? You have to play the right kind of game to channel a skill. So if they made a game that was really enticing for, let's say if you were studying economics, that you actually delve deep into economic concepts in the game, you would be a way better economist for doing it. So like SimCity back in the day, or what is it, City Skylines now, they had in-depth feature where you could play with like market and demand and whatnot, and see if you can like invent new products. Yeah, you're not as dumb as you may think. You'd be surprised. What is that TED Talk? Let's see. Let's see if I can find it. Gaming can make a better world. And it came out in 2010. Let me see if I can copy her name so you can look. Jane McGonigal. And I know it's a bit weird. Oh, I missed one. Tangents. Yes. This is always going to be a tangent. Jane McGonigal. Gaming can make a better world. TED Talk. I did, but now I don't remember it. I was half paying attention. Looks like the YouTube one is not so good. Interesting. Anyways, I was gonna do this one because this one seemed more critical thinking. Can you send me that Alan Watts video again? Oh, no, it's in my history. I could probably just find it in my history. I haven't watched too many videos. Okay, the graph of the solution is known to, okay. The graph of the solution of the given initial equation the given initial value problem is known to passes through nice. I'm actually gonna just link it and put it in my watch. Cool. Thanks, bud. Passes through the listed point, which would be t comma y. We need to find alpha and y0. Alpha and y0. So our question that we're going to work through is ty prime minus alpha y equals 0. And we've got y of 1 is equal to y0. And our point points 2, 1, and 4, 4. 2, 1, and 4, comma 4. Yeah, I like thinking. Thinking is a good thing. How's Mr. Panda doing anyways? Hacks Panda. There I am. Okay. We want to get the general solution first. Well, the general solution's not hard to find. We actually did one very similar to this already. We'll just divide by t. Y prime equals to negative alpha over t y equals 0. And we've got odd electric wires and a lot of metal. Where are you trying to install a monitor? Like, are you in your basement or something? So you've got concrete walls with metal or something? No, you'd probably be upstairs, right? Interesting. Top floor. Why do you... Oh, so you're just in that one awkward spot where the wires go through? Okay, just math is gay. Okay, so what do? We've got to go with our y are going to be our constant times e to the negative of the p of t, dt. And the p of t dt, our p of t, is negative alpha over t. So the integral of negative alpha over t is negative alpha, because alpha is constant, natural log of t. Okay. We're not going to write the constant in there because, yeah, Should I even explain why? Maybe. Nah. We just know there's a constant in front. That's good enough for now. So our y of t is going to be a constant in front times e. Negative times a negative is a positive, so we've just got alpha natural log of t. Using our logarithm rule, the alpha comes up, so y of t constant e to the natural log of t to the power of alpha. And, well, would you look at that? That cancels out, so y of t is some c times t to the alpha. Okay. Now we know what points it passes through. So we've got 2 of them, which means we can use those to find our values. So we need to find y0 and alpha. So what's our first one? Should we should probably find the derivative. Nah, we'll start with this first. If we want, I'll write this in here as well. So y prime t be some constant times alpha t to the alpha minus 1. So that's the power rule. Yeah, Simon. I'm feeling better these days, so I'm back on the horse. Although I don't have anybody to really tutor yet. I've had some requests on Instagram, but they've been short. And they were just like one little pieces. I do have this one kid that I tutor almost every day. But he doesn't want it streamed, so I just do it over Discord. I mean, we are getting slightly bigger. And by slightly, I mean more than myself. No requests so far. Yep, no requests yet. And okay, so we got 2 points. 2 and 1. You might have to tell me everything there is to know for the convergence of the halting problem. If you can tell me everything there is to know about it, I'll work with you. Truth be told, what I would really like is to have some people that have a passion, whether it's their work or science or economics or whatever, something that they're passionate about, come on and just talk with me through Discord on the stream, and we'll go through their passion a bit, and we'll talk about it. That'd be really fun to stream. So if somebody really wanted to talk about computer science, we do that for an hour. Just to mix it up a bit, because I don't have to, if nobody's to tutor, right? We might as well do something that's interesting. Y is 1 when t is 2. So we've got 1 is equal to c times 2 to the alpha. Well, yeah, we could, definitely, Mr. Panda. We can do some cryptography. I haven't done a lot of it, actually. Let me know what you want to do. We could do some cryptography on stream. That would be cool. Maybe we'll record it and put it on YouTube too. Even though everything we do right now is recorded on YouTube. And we've got a second point. 4 come 4. So y is 4. And we've got c again. And 4 to the alpha. Then we got 2 equations and 2 unknowns. I like to do another one with this. We'll use this. Why did I write this out twice? I'm not sure. Oh, I think I know why. My notes are missing something. Cool. And we plug in another value. What did I even write in here? Whatever. Yeah, I knew it. My notes are missing something. Anyways, we've got y is 1. Was y 0? What did I do? Am I having a mental break? Figure out my notes here. Oh, right. That's what I did. If I divide by 4, we've got, if I divide by 4 on both sides, we've got 1 equals c 4 to the alpha minus 1. And what is 4? 4 is 2 squared, right? And so 1 equals to c times 2 squared alpha minus 1. So then we've got, well, we've got 1 equals c times 2 to the alpha. We've got 1 equals c times 2 to the 2 alpha minus 1. Cool, cool, cool. We'll subtract the 2 equations. We get 0. We'll subtract the 2. And we've got c times 2 to the alpha minus c times 2 to the 2 to the alpha minus 1. And, well, what does that give us? Well, the c's we are the same, we won't worry about. We've got to get this to be equal to 0. So when they're equal to 0, we've got 0 equal to alpha minus 2 alpha where did I get the plus 2? I gotta check my notes again. This is a little off. Two. Weird. Why are my notes so off? Okay, let's just think about this for a second. All right, okay. Alpha minus 2 alpha plus 2 equals to 0. We've got, what is it? We've got minus alpha equal or plus 2 equals to 0. And then we scroll down a little bit. We've got alpha equals, oh, I hit the opacity for some reason. Alpha equals to 2. And now we can find C. Let's go back up here. 1 equals C2 to the alpha. So then that still shows on screen. Good, good, good. We've got alpha is 2. We've got 1 equals C to the 2 squared. So C equals, well, 2 squared is 4. We just divide by 4. We get 1 over 4. Alpha equals 2 and C equals 1/4. I gotta write my notes a little better. And C would be our y value, or y0. So if we go back to right here, y of 1 equals y0, then we can say, well, we've got our C value and our alpha value. Our general solution, y of t equals 1/4 t squared. The y of 1 is y0, so y0 is when t squared is 1, which is 1/4. Done. Okay. That was a start to first order differential equations. Let's see, what's another one we can do? Mathematical modeling? Did I do much in the modeling? I did a few. We can go through some modeling questions. They're just a bit more awkward. Sure. You know what? I'm just going to go right to this. Now, this is some mathematical models. A tank originally contains 100 gallons of fresh water. And at time t equals 0, there's a solution. Not a solution as in an answer, a solution as in a mixture of salt. So it contains, what does it say? 0.2 pounds of salt per gallon. And it begins to flow in the tank, to flow into tank. At a rate of 3 gallons per minute. And the well-stirred mixture flows out of the tank at the same rate. So well-stirred. Did I even spell stir right? No. Mixture flows out. At same rate. Okay, and if it flows out at the same rate, which is 3 gallons, how much salt is in the tank after 10 minutes? After 10 minutes. So that's the first part. There is a second part, but we'll go through the first part. So we're gonna say that our volume of our tank, V of T, is 100. Okay, so it's kind of like our position. It's 100. Our concentration inflow rate is 0.2, and we'll say pounds per gallon. Our rate of inflow is equal to 3 gallons per min. And well, our rate out is, well, 3, right? 3 gallons per minute. And okay, what is the quantity of salt in the tank after 10 minutes? So Q of T, quantity, at T of 10. That is our real question. So this is our information that we have. And our real question is, how much salt is in the tank after 10 minutes? So our differential equation will look like this. You've got D, Q, T, obviously, dt is equal to a rate inflow, rate Ri, T, times our concentration inflow of T, minus a rate outflow times our quantity over our volume. This is our differential equation that we have to work with. So let's plug in our numbers and see how we can simplify it, make it a little easier to work with. Well, Q prime is faster than right than dq over dt. Ri times Ci is what? 0.6? 0.6. And our rate out is 3. Our volume is 100, so we're just going to write 3 over 100. And Q is our quantity of salt. So that's what we're solving for. So then we notice that we can get this back into the differential equation that we had before. So the y prime plus e of t y equals, well, some number, e of t. In this case, we're a constant. Okay. I will be right back. Try to solve. I'll be about 30 seconds. Maybe 45. Okay. Let's do this. So I'm going to rearrange this so that it looks like our original function. So q prime plus 3 over 100 q equals 0.6. Because the 3 over 100 becomes positive on the other side. Okay. Now, we're going to take our mu of t. So we were doing this process before. And we're going to take e to the 3 over 100. And, of course, to t. Okay. Then, bring it down, bring it down. Then we're going to multiply both sides by the mu of t. So we've got e to the 3 over 100 t q prime plus 3 over 100 e to the 3 over 100 t q equals 0.6 e to the 3 over 100. Okay, this looks like our product rule again. So we're going to write e to the 3 over 100 t times q prime. And Belle's barking. I hope she's not being mean. This is 0.6 e to the 3 over 100 t. And okay. We integrate both sides. Boom. Boom. Where's my thing? I'm running out of space. We got e to the 3 over 100 t q equals, well, it'll be 100 over 3 times 0.6. 100 over 3 e to the 3 over 100 t plus some constant. 0.6 times 100 is 60. 60 divided by 3 is 20, right? So we're just going to write this as 20. E to the 3 over 100 t plus c. And we'll write another line. So e to the 3 over 100 q. Okay. Now, we multiply by the negative of this to simplify it out a bit. Get q by itself. 20. Well, these cancel out and these cancel out. Plus c e to the negative 3 over 100 e. And now we need to plug in our initial value. What was our initial value? We knew that the salt, or the quantity of salt at time 0 was 0. That's what it said in the question. Fresh water at the beginning. So there's no salt at t equals 0. So q of 0 is 0. Which means we got 0 equals 20 plus c. T is 0, so e to the 0, which gives us 1. We've got 0 equals 20 plus c. C equals negative 20. Okay. Now we'll finish our equation. What does it look like? Well, we've got y, or q of t, not y. Q of t is 20 minus 20 e to the negative 3 over 100 e. Okay, but that's not what we were looking for. We wanted q of 10. So what's q of 10? Hey, how's it going? What do you say? URAC unit 420? Or is it? I don't know how loud you would expect me to yell it. But, what is it? URAC unit? Or your ac unt? I'm not going to. Probably not. URAC unit is probably good enough. Q of 10. We got 20 minus 20 times e to the negative 3 over 100 times 10, right? And so this would just cancel out, and we'd have... Should I write it as a decimal? Maybe. 20 minus 20. I'll write it as in simple form, and then we'll plug it into a calculator to see what we get. We get e to the negative 3 over 10, or to the negative 0.3, and which equals what? Let's plug it into a calculator. (20) minus 20 times e negative 0.3. We've got 5.183. That's 5.18 is good enough. Pounds. Okay. That was our Q of 10. Now, what's our second part? The second part of the question is, does the amount of salt approach a limiting value as time increases? If so, what is this limiting value, and what is the limiting concentration? So basically, as time goes on, what does it reach? Does it reach what kind of value? What's the concentration? What's the amount? So the limit, as time goes on to infinity, of our Q of t is what? Well, let's look at it. So our function is 20 minus 20 e to the negative 3 over 100 t, right? If t goes to infinity, this is the same as saying 20 minus 20 over e to the 3 to 100 t, right? It's just easier to write a negative in the top. So as t approaches infinity, this number approaches infinity, right? It gets really, really big. And when a number is divided by a very large number, it gets really small. It goes close to 0. So this tends to 0. So our limit goes to 20. Of Q of t, 20. Easy. Okay, we've done differential equations. Just to start, we keep doing. Another concentration question, or these are all pretty similar. Population dynamics? (2.4) Population dynamics would be okay. What should we talk about? Population. Yeah, we could do this example. Okay, what I'm gonna do, I'm gonna scroll all the way, well, how much further? Not very much. We'll scroll all the way up to the top. Go through everything we've gone through today. There's actually quite a bit. And then we'll just slide on over. Okay. Population dynamics and radioactive decay. And okay. I'm not gonna do this. I'm gonna do bacteria in a petri dish first. So bacteria in a petri dish is modeled by this differential equation. The population is equal to some constant. So the rate of change of the population is equal to the some constant times the population. So we've got 100,000 as our initial. So P0 is 100,000. And we're doing bacteria in a petri dish. Okay. Then after 2 days, our population has grown to 150,000. 150,000. Okay. Find the growth rate Okay. Well, that doesn't seem too difficult. And estimate the bacteria. After 7 days. Now something tells me I did one similar to this for an Instagram post. Pretty sure I did. Let's double check. I know I did one similar. Ah, yeah, I did. Colony of bacteria has 10 million members, but after 5 days it increases to 11 million. What's the population after 30 days? No comments though. Nobody guessed. Although I do have 183 likes on my wheel. That's a good start. Okay. Well, we know the general solution is going to be some function of P of t is going to be C e to the kt. We know that because we already did a bunch similar to this. T, however, is measured in days. Sometimes you could have a population measured in months or years, so it's good to write down what your time scale is, because they might give you a time scale of a month, but the equation works in days, or vice versa. They might give you days, but it works in months, or something like that. So I mean, we already know the solution, right? So P of 0 is 100,000. Oops, I wrote 100 twice. And this is equal when T is 0. So C equals, well, this is e to the 0, which is 1, right? So C equals 100,000. Then we know, this is what it was given to us, is P of 2. So 2 days is 150. Right? Then we've got 150 equals 100 e to the k times 2, right? Because it's t is 2. So we'll divide by 100,000. 150 divide by 100 equals e to the 2k. So what's an easy way to say this? Just 1.5? Yeah, let's do 1. 1.5 is equal to e to the 2k. We want to get rid of the e though, because we're solving for k. So we're going to take the natural log of both sides. We get natural log of 1.5 is equal to the natural log of e to the 2k. Using our log rules, this is just 2k. So then we've got natural log of 1.5 is equal to 2k. K equals natural log of 1.5 over 2. Nice. So we need now the population after 7 days. Now, of course, we can't be exactly precise, but this is a model, right? So our population, T, is equal to 100,000, which is our initial, times e to the, what is it? EKT, right? Natural log of 1.5 over 2 times t. We're going to sub in 7. So P of 7, 100,000, e to the natural log of 1.5 over 2 times 7. I mean, we could change it. We could simplify this. Yeah, let's simplify it first. Because technically, I guess on your test, you would have to simplify it first. I'm trying to think of what the most ways to make it easy for university tests. So what I'm looking at here is this is the natural log of 1.5 with a 1/2 in front, and there's a t, right? which then we could say, well, let's erase this 1/2, and we'll go over to here, a little nicer, times t over 2. Then with that, they cancel out a bit, which then gives us 100,000, and we get 1.5 the power of t over 2. See that? You see that? And now we'll plug in t of 7. 100 times 1.5, 7 over 2, which, if you type it into your calculator, boop, boop, beep, we get 413,000 bacteria. Which is a good estimate. I think so. What else? A different model. Ooh, this one so the first one didn't incorporate death. I know that sounds really bad, but the next one does. So we've got a birth rate and a death rate involved in the next one. Okay. Birth rate and death rate. So this one is an aquaculture firm, raises catfish in ponds. At the beginning of the year, the pond contains 500,000 fish. So at t equals 0, we've got 500,000 fish. Okay. The net growth rate coefficient, so the rate of death, or the rate of birth, I should say, rate of birth minus the rate of death, is estimated to be about 6.1 per 1,000 per week. 6.1 per 1,000 per week. That already sounds like a mouthful. Firm wants to harvest at a constant rate R. To harvest at a constant rate big R, big upper R. And they want to do per week as well. Okay. But it also wants to increase the population to about 600,000 fish by the end of the year. But wants 600,000 fish by end of year. Find the appropriate harvest rate R. Find R. This makes a lot of sense in what you might find in a trade question. So our model now is going to be d by dt, and we've got our rate, so our birth rate minus our death rate acting on our population, plus the migration rate. So the migration rate for us would be considered the harvest rate. R plus R. But we are going to be taking away minus R. There you go. So we would add R if we were adding people to it. So like if a city was growing, we're adding to it. But we want to take away from it. We're harvesting. So we're going to take away our harvest rate. And the harvest rate is positive. We've got our population to begin with is 500,000. Our rate of birth minus our rate of death is 6.1 per 1,000. So 6.1 over 1,000. And that's per week, of course. Which gives us, you move the decimal point 3 places, 0.006 inverse weeks. Okay, so this reduces our equation to dp dt 0.0061 p minus r. Now let's solve. We need to bring our population over. We know our solution's going to be we want a harvest rate R such that P of 52, because there's 52 weeks in a year, is what, 600,000? So we need the what am I changing here? We need the general solution, the non-homogeneous. Okay, so P prime minus 0.0061 p equals to negative r. Okay, and we're going to take we were just doing this e to the negative 0.00. We're going to multiply it on all sides. Right. Yes. And then we've got e to the negative 0.0061 t e prime minus 0.0061 e to the negative 0.0061 e equals negative r e to the negative 0.0061 e. We're going to integrate both sides. So this is like the questions we were doing before. It is the product of these two functions. So e to the negative 0.0061 e times p prime equals, if we integrate both sides, we get r over 0.0061 e to the negative 0.001 t plus a constant. Okay, plus a constant. Oh, hey, I'm integrating before. Should let this stay the same. E to the negative 0.0061 t. Okay, integrate both sides. Ching, ching. So now we've got e to the negative 0.0061 t. E equals, now the negatives will cancel out. We got the r over 0.0061 t. E to the negative 0.0061 t plus your constant. Okay, okay. Now we will multiply by the positive of this exponent over here. So we've got p, because they'll cancel out. So multiply the whole thing by e to the 0.0061 t. And p equals, well, this will cancel out, so we're left with an r over 0.0061 t plus some constant e 0.0061 t. Okay. Now, we've got our population model. How much is pi? 3.14 something. Actually, you can determine pi lots of ways. It's true. You should try it. There is using a perfect circle. There is some fancy integrals that'll give you pi. There is a infinite sum that'll give you pi. What else? Lots of things. Lots of things. Okay. Let's finish this differential equation. So we've our initial condition, b of 0 equals 500,000. And so what is p of 0? Well, that means t is 0 and p is equal to 500,000. 500,000 equals did I write this? Oh, I shouldn't have a t there. I'm silly. Why did I write a t there? That's why it looked funny. There. R over 0.0061 plus some constant. E to the 0 is just a 1. So our C equals 500,000 minus R over 0.0061. Okay, so then our differential equation becomes, so we've got R over 0.0061 plus 500k minus R over 0.0061. Okay. And then E to the 0.0061 t. Now, we have to find R. So we want to choose R such that E of 52 equals 600,000. Okay. Now, let's plug this in. 600,000 equals sum R over 0.0061 plus 500,000, 1, 2, 3, minus R over 0.0061 e to the 0.0061 times 52. Now, do I bother with doing a whole lot of this? Or do I just say that the answer? Let's just write the answer. Calculator work is lame for now. I mean, we're doing math. We're not doing calculations. So we've got R, if you solve it, should give you 14.16 per week. If you have to round, you would just round to 1400. So 1400 harvest rate. We actually did quite a bit of work for that question. Okay, so we go back, because I was going really fast for some reason. I don't know, I just got excited, I guess. So there's a fish farm that has 500,000 fish at the beginning of the year, and their net rate of births versus deaths in the fish, because obviously some fish will die, is 6.1 per 1,000 per week. The firm wants to harvest at a constant rate R per week, but it also wants 600,000 fish by the end of the year. So we need to find the harvest rate. Our differential equation, dT equals RB minus RA, or death, so I should write this as a little bit bigger, times the population minus our rate that we harvest. We got our initials at 500,000. Our birth minus death rate is equal to 0.61 per 0.0061 per week. Plug it in, simplify our equation. We got dp dt equals 0.0061 p minus r. We solve our differential equation. And find our value for C. We solved our differential equation. We find our initial constant, which ends up being 500,000 minus the rate divided by 0.0061. Then, with that, we can determine our rate by having our population that we want after 52 weeks is equal to 600,000. Okay, we've done differential equations for how long have I been live? Almost 3 hours. Really, almost 3 hours. It's been pretty fast, actually. I haven't had it go this. Oh, and there's a sun in my eyes now. There, that's a bit better. Okay, let's no longer do differential equations. Now, some people have to do high school math. I want to go through some other things as well. We're gonna get rid of this. And let's do some review stuff for first year calc. Because first year calc's coming up and we need reviewing. Let's see what they want us to do to review before your first year of university. Numbers, inequalities, and absolute values. It's not too bad, I guess. Coordinate and geometry lines. I don't know if that was really that important. Mostly just like distance, slope, and equations of lines and stuff. Graphs of second degree equations. So, like a circle, a parabola. I guess a hyperbola. Other conics. Let's see what else. Trig. Should go through trig. Definitely go through trig. Sigma notation. I don't know if it was really that imperative. Proof of theorems. No, we don't need to do. Okay. Since we've done a lot of the absolute value and inequality stuff, let's go to the coordinate geometry and lines. Just a review of that first. Okay. So, what time is it? Almost 20 to 6. Okay. First of all, we know our y-axis and our x-axis. And we're going to draw a line. Well, let's start with a triangle. Here. Okay. We've got this line and the triangle. This is our let's say our x 0 and our y 0. This distance is what? Well, we know the Pythagorean theorem. So this is the what? The square root of x0 squared plus y0 squared. Okay. And that's easy because it's at the origin. And this point here is 0, 0. What is the distance between any 2 points? So, like, this point here, we're going to call it A, comma, B. And this point here, we'll call this C, comma, D. What is the distance between these 2 points? Well, the distance between 2 points I'm going to change this to review. And let's see, did YouTube get anything? No. Nothing. Makes sense. Honestly, YouTube doesn't even look that good. Looks like a worse quality. Okay, distance function, which we will write as difference between 0.1 and 0.2 is equal to, we've still got the square root, so that Pythagorean theorem still works. Now, what I'm going to do here is I'm going to draw a line like this. I'm going to draw a line like this. And we're going to figure it out as well. Notice how that's a triangle. And Josh's Beast. Thanks for the follow, bud. Welcome. Don't go insane. I mean, it happens. Just don't go insane. Okay, we're gonna what I'm working on is a review for first year. And what is this length here? This x length. Well, it would be the distance from here to here, which would be what, c minus a? Or a minus c, or something like that. So this is the difference between x's. And this would be the difference between the y values. Difference between y. Josh, are you still here? Let me know. So the difference between y's and the difference between x's is just like this formula in here. So we've got x2 minus x1 squared plus y2 minus y1. We could also have the distance formula extend to 3 dimensions or 4 dimensions, and we just add each dimension to it. By the same logic, there's triangles in 3 dimensions, 4 dimensions. And what else do we need to review? They want slope of a non-vertical line. Well, slope of a non-vertical line. Slope of a non-vertical line. Slope of a non-vertical line would be the rate of change of this line. And let's call this point here and this point here. This, what did they say? P2 and P1. And they'll both have their corresponding x and y components. And the slope of the line is how much it changes in its rise versus its change in its run. Rise and its run. So its changes in y and its run is its changes in x. Okay, so what does that look like in our formula? Well, our slope m is change in y over change in x. So it would be our difference between y2 minus y1 over our difference between our x's, x2 minus x1. Okay. I'm probably talking further away from the mic than I should be. Let's see if I can turn this a little better then. Because I don't need a calculator. Oh. I got so into it, I forgot to look and make sure I don't right the other way. Okay. What was next? What do they want? Equation of a line. So you've got an equation of a line. And slope m and y-intercept b. Slope of the line is y equals mx plus b. The one thing that you will remember forever for the rest of your life for some weird reason. Don't ask me why, it just happens. What? Alex, you have a question. What's 4 times 7? Now, the question, Alex, is what way are you taught to do multiplication? Because what I've seen lately is you should take, 4 groups of 7 and add them all up. Or just do it adding 7 4 times. Or doing 4 7 times. So, Alex, how would you do that multiplication? In fact, what I would do is break it up into simpler numbers. 2 times 7 plus 2 times 7. And the only thing is, YouTube doesn't have timestamps. I don't know how long that question's been there. I think maybe already left. Possible. Anyways. You could also write the equation of a line in general form, which may happen, is ax plus by plus c equals to 0. You know that equal to 0. Parallel and perpendicular lines. Last bit. What is the difference between a parallel and a perpendicular line? Well, parallel lines never meet. Perpendicular means they have a 90 degree between them. So what is the slope of these lines? Well, in parallel lines, they have the same slope, so they'll never intersect. So slope 1 for parallel, m1 equals m2. Perpendicular lines. Perpendicular lines are negative reciprocals of each other. So that means the slope of the second one is equal to the negative reciprocal of the first. So if you've got y equals 2x plus 1 as your first line, and you need a perpendicular line to that, you would just look at the slope. And a perpendicular line to that would have a slope of negative 1/2. Now, let's do a couple examples. Now, a couple examples could be... Let's do this one that's a little more complicated. So, another thing you could say is m1 times m2 is equal to negative 1. You wanted to do it that way. Show that the lines 2x plus 3y equal 1 and 6x minus 4y minus 1 equals 0 are perpendicular. I like to just write the symbol as a short form. Now I'm going to check Instagram to see if anybody has sent me a request. Nope, no request. People don't have homework these days yet anyways. Although I'm hearing that some high school students are already back in school. Nothing so far. Cool. Let's solve our equation. So when are they perpendicular? Well, let's rewrite them into slope-intercept form. We've got 3y, and we're going to bring the 2x to the other side. So minus 2x plus 1. So y, if we divide by 3, we've got negative 2 over 3x plus 1 over 3. There's 1. Let's do the other one. We'll take the 6x and the 1 to the other side. So we're left with negative 4y minus 6x plus 1. So the 1 becomes positive. We take it over. 6x becomes negative when we take it over. Now we're going to divide by a negative 4 to get the y by itself. So negative 6 divided by negative 4 is just positive, but the 6 is 2 times 3. 2 times, not 0.3, 2 times 3 over 2 times 2. We're going to cross out one of those 2's, so we get 3 over 2 x and minus, because the minus sign on a positive is a minus, we've got negative 1 over 4. And then we need to find out if their slopes are perpendicular. So, to find if a slope is perpendicular, we can say that the m1 times m2 is equal to negative 1. First slope and second slope, negative 2 over 3 times 3 over 2. Now, does this equal negative 1? Well, the 2 cancels out, the 3 cancel out, we get negative 1 equals negative 1. Yes, they are perpendicular. Cool. Cool. Alright. Almost 6 o'clock. It's time for a break. And dinner time. So, what I'll do is I will end the stream for now, and I will probably come back a little bit later. Thanks for anybody who stopped by and anybody who followed. Check out my Instagram and Twitter for some extra stuff. And I'll talk to you guys later.